Can you see me?
Yeah.
Okay, good. Okay. So today is really nice to see a big turnout for the seminar. And so we have Dom to give us a talk on his research on biomass and the value of livestock in Indonesia, weighing up the impact of livestock and disease. Dom is an agriculture economics with over 30 years of research and development experience throughout Southeast and East Asia, and a strong track record of successful acquisition, implementation, and management of complex programs and projects. Most recently, he has led a suite of research for development projects supporting governments and the private sector agribusiness related decision-making in Vietnam, Laos, Cambodia, Myanmar, Indonesia, Timor-Leste, and the Philippines. Dom is currently leading the policy, social, and economic impact assessment of global burden of animal disease, case study in Indonesia, and leading the Australian-Vietnam Enhanced Economic Engagement Grant Project, reimagining collaboration in Australia and Vietnam beef cattle sectors. And today is Tarni is sick, so she cannot join us. So now I pass the floor to Dom, and you may start.
Great. Thanks, Gloria. So I'm presenting today on behalf of all my co-authors who are listed up on the screen there. My co-authors are from BRIN, so that's the National Research Agency in Indonesia, and also from CSIRO in Australia. And we recently published this research in the journal Preventive Veterinary Medicine. I can share the link with you for that. It's open access, which is the best access of all, so everybody will be able to read and enjoy. So this presentation is based around that article, but we also have additional material courtesy of our GBAD's global team and Professor Jonathan Rushton at Liverpool University. So I'm involved in the research, but it's not just me. I'm just part of a very large team. I'd like to start off by acknowledging the people who are the traditional custodians of the land in which we're meeting and working today. And that also extends to the traditional custodians of the land where people are online joining this meeting. We pay respect to elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples. I'd also like to just give you a bit of overview about GBADS. GBADS means Global Burden of Animal Diseases. There's a lot of logos up on that screen, and the top line of logos are the funding bodies, so including ACR, IDRC from Canada, Bill and Melinda Gates Foundation, which is a major funder, Foreign and Commonwealth Development Office in the UK, et cetera, and then a lot of partners in implementation. So the global program is led by WOA, World Organization for Animal Health, that used to be OIE, and the University of Liverpool, and then with a lot of collaborators around the world. And we have a case study under this global program in Indonesia, and that's led by CSIRO. And I have at least 2 colleagues from CSIRO online today, so thank you for joining. And Griffith is a partner along with BRIN, Indonesia, in implementing that Indonesian case study. So overall, what are the challenges for the livestock sector around the world? Demand for food is growing, and in particular, demand for animal protein is growing. We've seen an uptick in plant protein, and then more recently, maybe a little pullback, especially in developed countries, around demand for plant protein. But demand for animal protein is definitely increasing around the world. But that also comes with increasing pressure on the use of land, water, and air. We're seeing increased connectivity and movement across livestock sectors. We've been working for the last 10 years on livestock value chains in Southeast Asia and East Asia. And it doesn't make any sense anymore, for example, to talk about the Vietnamese livestock sector or the Lao livestock sector or the Indonesian, everything is interconnected, and there's animals flowing, money flowing across borders, and sometimes very long distances. So, for example, in China now, the largest supplier of beef to China is Brazil. It's billions of dollars of beef going from Brazil to China every year, followed by Indonesia, followed by Argentina. And with that increased connectivity and movement, we're seeing a lot more flow-on effects. So, for example, a change in the quota system for beef in Indonesia can drive changes in supply and prices in Australia, which in turn impacts on supply prices in Myanmar. So there's a lot more connectivity. There's greater awareness these days of the impacts of livestock on the environment and on public health. We're all very well aware of the greenhouse gas emissions from beef cattle worldwide, in particular methane emissions. But in many ways, there's limited awareness of the wider importance of value for animals in society. People who've worked across the Pacific or in many parts of Southeast Asia know that pigs and cattle in many places have far more than monetary value. They have extremely high social value and cultural value as well. So often we concentrate on the numbers and on the economics and on potentially the environmental impacts, but we don't see so much about the social impacts and the social good that comes from animals in society. And there's increasing pressures on investment budgets, that's public and private investment, to support the livestock industry and especially around animal health and welfare. So our animal exports from Australia are extremely sensitive to animal welfare. We have some of the best standards in the world for animal welfare, and increasingly countries in Southeast Asia are adopting those standards as well. So things are changing, maybe in some ways slower than they could. So what's GBADS? So GBADS is a multinational and transdisciplinary consortium led by University of Liverpool and WOA. It's funded by, as I said, Gates, FCDO, European Commission, ACR, IDRC, and Brook, amongst others. And it generates estimates of social and economic burden of animal diseases. So it means the cost, both monetary cost and social cost of animal disease. And the idea is that will provide data and information that supports sustainable health investment and sustainable development of the sector. Better information leads to better decisions lead to better outcomes. The analytical structure really takes, it starts with looking at livestock population. The population of livestock is, and accurate estimates of population are the basis of everything that we do in this program and beyond this program as well. If we talk about the impact of cattle on methane emissions, for example, if you don't know how many cattle there are, then how can you say what the methane emissions are? It's impossible. Recently in Australia, we've had a discrepancy of around 3 million cattle, so it's around 10% of the population of cattle between Meat and Livestock Australia estimates and Australian Bureau of Statistics estimates. 10% difference. But other studies, one done in 2021 out of QAFI and UQ, estimated, and CSIRO, estimated that we might be 10 million wrong. So that's 33% wrong in our population estimates. So accurate estimates of livestock population form the basis of any of our work. Once we have livestock estimates, then we need to estimate biomass. I was talking to Jing this morning about biomass being that it's very hard to compare. If you say, I have 10 cattle and 50 chickens, so you can't compare 50 and 10 because chickens don't weigh the same as cattle, obviously. So we convert different types of livestock to their weight, and that enables us to compare. Once we have the weight, then we start to calculate the value of animals and their outputs, so we know how much the sector is valued at. The next step after that is to look at look at a benchmark or an ideal state to say, this is what the livestock sector could produce in an absolute optimal state. And the difference between what we do produce and what we could produce, that gap is due to animal health. So it's due to disease, it's due to misadventure, it's due to poor nutrition, etc. But that gap is what we're looking at as a measure of the burden of animal disease. Once we move beyond that, then we start to break it down by disease. So how much of that gap between what could be and what is because of foot and mouth disease, how much because of brucellosis, how much because of TB, how much lumpy skin disease, for example, or African swine fever in pigs. All of those are at the farm level. But then we also look beyond the farm level to the impact across the economy. So it's not just farmers that are impacted by poor animal health. Traders have less cattle to sell. Input suppliers don't sell as much feed because there's animal health problems. So we're looking at farm level burden and society and economic burden. This example here is from the global burden of human disease, or it's known as global burden of disease. So this work has been done for humans. It took 30 years to get this done for human beings. But you're able to look and see, okay, in this particular country, how much is the cost of strokes? How much is the cost of lung cancer? How much is the cost of breast cancer? How much is the cost of headaches, hearing difficulties, etc.? What burden does that place on society as a whole? And if you know that picture of the breakup of the burden of different types of disease, then you can start to make better decisions about where you're targeting your investment. You know, if I was a government department, would I spend more money on diabetes or on depression or on anxiety or on preventing strokes, etc.? We're not. HD is heart disease. Anyway, so this is what we have, and this is available online for almost every country in the world, and you can look at it in terms of morbidity, so like how sick people get, and mortality. So you know the people pass away because of these problems as well, and that's what we're aiming at for animal disease as well. But probably, as you can imagine, the level of complexity of doing this for animal disease far exceeds the level of complexity of doing it for humans. Animals don't turn up to the doctor and get diagnosed and then etc. And we can't make an accurate, it's very difficult to make for humans, we can say, okay, they lost this many days of productive work, right? Because of their migraines. Right? And then we can add all that up and say, okay, this is what could have been in terms of their work compared to what is now. Now, it's very difficult to do that for animals. They're used for draft, they're used for meat, they're used for eggs, they're used for milk, etc. And also, often we don't know what disease they have. You ask a farmer, okay, your chickens died, what did they die? I don't know, my chickens died. So we're at the start, and this has been going since around 2018 of a long journey to get global burden of animal disease. So what can GBADS potentially offer? And this is what we saw for Indonesia. So it could offer a national estimate of the burden of animal disease. At a regional level, we could also do that. So different parts of Indonesia, different burdens for different livestock species. So what's the burden of disease in cattle compared to pigs, for example? Burden of particular types of disease. So foot and mouth disease is a very hot topic in Indonesia. So how much does that cost Indonesia every year? The burden of disease in different production systems, so extensive production system versus intensive, and then human health through zoonotic diseases, the social impact, the environmental impact. So there are plenty of different offerings from GBADS. So we like to think of them as a suite of offerings. So it's not just the end product, which is this is the burden of animal disease, but there's a number of different products We are, as I said, Indonesia is one of the case studies. We have the first case study was in Ethiopia. So they started off a couple of years before us. We've been going in Indonesia now really well for about 1.5 years. Senegal did a small study, and now we see also in Europe there are some studies coming along in Ireland, and I think one of the colleagues from Ireland is online today as well. UK, Netherlands, Norway, and there are other studies around the world being initiated, including Australia is hidden behind the view of the room, but there's also, I'm not sure how we can do it. In any case, in Australia, we're also planning to do an estimate of the burden of animal disease. So, and for Indonesia, this work really represents right at the beginning. So we're estimating, we're testing the validity of the population data, and then we're estimating biomass and estimating value. We need to do that first, so then we can estimate the burden of disease. We need good estimates of the population, and we need, before we can draw any conclusions about the socioeconomic burden of livestock disease, we need to know the distribution of livestock. And calculation of the animal biomass and comparing that with human biomass and the distribution can also provide insights into environmental resource challenges. So we needed quite a bit of data in Indonesia. Most of our calculations are based on secondary data sources, mostly from Statistics Indonesia, but supplemented with work that we're doing in the field. We had to develop a novel model to calculate the biomass and livestock value, and we did this from a period of 2017 to 2021. As I mentioned right at the beginning, accurate population data is at the basis of everything that we do. So the first thing that we tried to do was really test how accurate the beef cattle data in Indonesia were. And the way we did that was using herd dynamic modeling. So that means that we had an estimate of the amount of beef produced and an estimate of the total population. And then we ran that through a model to show, is it actually possible that you could produce that much beef from this many cattle? And we did that for all the different provinces of Indonesia. And we developed a set of criteria. So like the age at first calving and the average weight of turnoff. And those estimates were within the bounds of possibility. Right? So they seemed logical. And then what we did was we put those estimates into a dynamic model, and we ran it for 5 years, and we compared the population estimates that we got at the end of 5 years with what was reported in the statistics book. And I'll give you the result in more detail a bit later, but in any case, they were consistent. So the conclusion was that at least for beef cattle, the data that we're using are relatively good and internally consistent. We were recently in Nusa Tenggara Timor, and the officials there mentioned that the pig data is not so accurate. So we need to do more work on that. So we calculated by province the biomass. For most types of livestock, we use the average live weight per head. So in Indonesia, they normally publish like information about what the average weight of broiler chickens is, the average weight of sheep, the average weight of goats, average weight of cattle. But for beef cattle, because beef cattle are so important in Indonesia, we didn't use one single live weight estimate. The Indonesian government uses 250 kilograms as the average live weight of cattle in Indonesia. But what we did was look at different breeds of cattle, male and female, at different ages, what their average weights were, and then split the population into breeds and sex and age group, and multiplied all of that together. And that took a long time, as you can imagine, to like scout through the literature and get all the studies and everything. And we came up with the end figure after all that work was around 5% different 250 kilos. So, but it was still very worthwhile to do. Livestock value. So if we talk about the total economic value of livestock, it's like split into two main parts: the use value and the non-use value. So the non-use value is altruistic value. It's the bequest value, like what you would give to your children. The value of livestock actually existing within a system. And then there's the use value. So we have direct use. So that's the standing population, the outputs that are produced, and the services, for example, using buffalo to pull a plow. And this is a service provided by animals. There's also indirect use and option value. For our study, we concentrated on direct use value and on two parts of direct use value. So the value of the population as a whole, and then the value of primary outputs of the population. So, and I'll list what those. So we have and it's calculated at the farm gate level and based on farm gate prices. So we have different types of livestock: beef cattle, dairy cattle, buffalo, pigs, layer chickens, broiler chickens, local chickens, sheep and goats, and then different outputs for each type of livestock. So for beef cattle, it's slaughter cattle and cull cows. For dairy cattle, it's milk and cull cows, etc. Buffalo for slaughter, pigs for slaughter, eggs, broilers are broilers, local chicken is eggs, and etc. So our value has two parts: the value of all the animals that are there, and then the value of the outputs that they produce within 1 year. So this is consistent with livestock value studies done in other parts of the world, and indeed recently done at a global level as well. Obviously, we haven't captured all of the value. You can see there's like a big chunk of that total economic value that we haven't captured here. So this is very much a first step. We can say in terms of economic value, this is the largest part, but just to emphasize, it's not the total value that we've captured. So as I mentioned, we come to the results. So the first part of the results were about our validation of the reported cattle and production data. When we ran our model from 2018 up to 2021, we found that the model generated a 2% difference in the total population compared to what Statistics Indonesia said, and less than a 10% difference in the offtake. So that means the cattle that are slaughtered, which is very close in terms of over a number of years. And then the fact that, especially for slaughter, the slaughter doesn't only depend on biologic factors and time, it depends on market conditions, etc. So the conclusion was that the data that we were using from Statistics Indonesia for cattle, at least, were reliable. So biomass. Total livestock biomass in 2021 in Indonesia is 12.2 million tons. So that's around, that's dominated by cattle and broiler chickens. So between those two, it's around 77% of the combined biomass. Why? Because cattle are very heavy compared to other types of livestock, and there are quite a lot of cattle in Indonesia, and there are a lot of broiler chickens in Indonesia. So broiler chickens only weigh about 1.5 kilos, but there are many broiler chickens. So combined, they have like the dominant part of the biomass. For comparison, that's around 75% of the human biomass in Indonesia. So human biomass is greater than livestock biomass in Indonesia. It's also very interesting to compare. They had a very interesting talk at the beginning of the year by a student who was working with Sarah about the biomass of livestock in Australia. It's almost exactly the same. Biomass of livestock in Australia is just over 12 million tons, so 12 billion kilograms. The main difference is in Australia, the majority of the biomass is beef cattle. so far more than Indonesia, because we have more cattle than there are in Indonesia, and our cattle are a bit heavier than the Indonesian cattle. So I thought that was like quite interesting to think, like whether Australia had higher biomass or Indonesia, but in fact it's almost exactly the same. So biomass is not evenly spread across Indonesia. I think people that know Indonesia know that it's such a vast country, stretching all the way from Papua all the way across to Aceh, the tip of Sumatra. It's an enormously wide country with a lot of variation in population density and other things. But biomass of livestock is concentrated on the island of Java. So, and West Java, Central Java, and East Java, 3 of the provinces on that island, account together for almost 50% of the total livestock biomass in the country. And it's quite, you can see they're the three provinces at the left-hand side of this table. You can see like the difference is enormous. Like it's really concentrated in those provinces. The average livestock biomass per kilometre squared is 6.3 tonnes, but there's enormous variation between provinces. So it can be 10 times higher than that in the provinces where there's dense livestock. The other very interesting thing, which we'll discuss a bit more later, is that there's a very strong positive correlation between human and livestock biomass, the density of human biomass and the density of livestock biomass. So where there are more humans per square kilometre, there's more livestock biomass per square kilometre. So, and where there's less humans per square kilometre, there's less livestock per square kilometre. So you've got a lot of people and a lot of livestock in very small spaces. Yogyakarta, in West Java, in East Java, very concentrated. And the R squared is extremely high. So, 0.88. So it means like there is a very strong positive correlation between human density and livestock density. Livestock value in Indonesia is more than 52 billion USD, so it's a very high value. Our colleagues in the ministries and the departments in Indonesia are very interested to learn about this high value. It helps them a lot it will help them a lot, I think, in lobbying for greater resources for livestock. Similar to the biomass, is dominated by beef cattle, but broilers and layers are also very significant contributors to the livestock value. This is in constant 2017 US dollars. So even in constant dollars, it's still increasing. The value of livestock is increasing across time in Indonesia. Remember before I said that the value is composed of population value, so the value of the animals that are there, and then the value of the outputs. So beef, cattle, and pigs, they have a large population value. You've got big stock of pigs and a big stock of cattle, but their production value is relatively lower compared to the population value. So, for example, you have a very big, expensive cow who produces a calf, maybe one calf a year you're selling as the output, for example, or she stays alive for 8 or 9 years and then is slaughtered. So the population value is generally bigger. But for chickens, and especially for broiler chickens, the value is production value, because the turnover is very high, very fast. So that's the difference between different types of livestock in terms of value. The total value of livestock is the greatest in West Java and in East Java. So East Java is mostly beef cattle. So there's around $8 billion worth of beef cattle in East Java province. And in West Java is broilers. I know you have to go, so thank you so much. It's broiler chicken. So that's the absolute value. So it's like many billions of dollars worth of livestock concentrated in those provinces on Java. But when we look at the value of livestock per person and the value of livestock as a proportion of GDP of a province, The highest is in Nusa Tenggara Timur. So for those of you that know Indonesia, that's the poorest province of all in Indonesia, but it has the highest value of livestock per person of anywhere in Indonesia. It's dominated by cattle and pigs, and these are stocks of people keep cattle and pigs as for cultural uses, and also especially for cattle they keep as a bank. You know, if you need money urgently, okay, you've got this bank of money there, and then you can sell. So it's a store of wealth and also for sociocultural purposes. So there's a big difference between the absolute value of livestock, where that is, and then per person, where livestock is very important. So there's two different measures of importance, I guess, of livestock in Indonesia. Finally, we looked at how sensitive the results were. So we did an arbitrary measure, which is varying the key inputs by 20% and seeing what happened to output values. So biomass was most sensitive if we changed the average weight of chicken or cattle. So changing those factors by 20% induced like quite a large change in biomass. And then livestock value was most sensitive to cattle price and also chicken price and egg price. So, and then the other factors like milk price or the buffalo price has a very small impact on the overall value. So discussion. Livestock value estimation is quite useful for policymakers. As I said, overall value of livestock, 52 billion, is very important for the Directorate General of Livestock and Animal Health Services to lobby for more resources. It's also very useful for determining development policies. And if you want to develop livestock further in Indonesia, where would you look at development? And having a detailed breakdown of the value of livestock by type and by province can you assist in performing cost-benefit analyses of policies related to livestock development and animal health. Indonesia and Australia as well have spent a lot of time and money on dairy policy research in Indonesia. It's been 30 years of dairy policy research. This little square graph here shows the value of different types of livestock in West Java, which is the concentration area of dairy cattle. And you can see like dairy cattle is the tiny little light blue square down in the right-hand corner, but it occupies a lot of time and resources and effort in terms of policy making, whereas sheep are far more valuable in West Java. Even beef cattle and broilers are far more valuable. So it's somehow it's also good as a method of like focusing ideas and attention for priorities in policy making. So biomass and livestock value is concentrated in Java. There are very dense populations and there's very high production values. So disease control measures like vaccinations, biosecurity could have relatively high cost-benefit ratios in those areas. You don't have to travel too far to encompass a lot of livestock. The value of livestock in East Nusa Tenggara is the highest in the country per person. Any policies in that area should really take into account the potential impact of African swine fever, for example, or foot and mouth disease. Any disease that could have like a very severe social and livelihood impact in East Nusa Tenggara. We're already seeing a change in the production system of pigs, for example, away from keeping a sow and having piglets towards a less risky but higher expense of just fattening pigs, so you can avoid the swine fever season, for example. The significant biomass loads per kilometre squared are leading to pressure on resources and the environment. The co-location of high human and livestock biomass is also much higher risk for zoonotic diseases. So with any policies to increase livestock production in Indonesia, they have to consider the existing biomass loads and carrying capacity. I've put back that graph showing like the extreme correlation between human density and livestock density. But the picture on the right is of the Citarum River, which is in West Java. It's the main river in West Java, and it's frequently referred to as the most polluted river in the entire world. And it really is like quite amazing. It's cleaner now, thanks to the efforts of a lot of different projects. It's cleaner now than it was before, but it's extremely polluted, and instead of just it's a living, breathing example of what the impact of that higher biomass of people and livestock. So currently, we're based on our work on biomass and value. We're working on the socio-economic impact of animal diseases in Nusa Tenggara, Timor, and East Java. I've been away the last month or so, most of the time with colleagues in Indonesia, in Nusa Tenggara, Timor, doing farmer focus groups and key interviews and value chain studies, looking at the socioeconomic impact of disease. So that's what we're doing at the moment. And in the future, our project is ongoing, but we've also applied for a grant from Connexi, which is the Department of Foreign Affairs and Trade program, to continue our work. And if we get that, then we're looking at a more deep dive into cattle disease impact, so including lumpy skin disease, linking with some trade models to see the impact of animal disease on trade and the environment, and then linking with the global livestock environmental assessment model, which is from FAO. The little diagram I put there is showing the extreme CO2 emission, or the extreme carbon emissions from cattle compared to other types of livestock. South America is the largest emitter by far, but Southeast Asia and to a lesser extent Australia and New Zealand also have a lot of carbon emissions. So we'd like to take our work and look at the potential impact of improved animal health. If animal health is improved, then the efficiency of production can be improved, and potentially the carbon emissions can be reduced. So a big thank you. We have just recently we have two publications, one in preventive veterinary medicine about the value of livestock, and then one in the OIE Scientific and Technical Review about understanding decision makers and their needs in terms of animal health. So both open access. If you like, I will be able to share this presentation, so you'll be able to download it. So I think I went a little bit over time, but if anybody has any questions, also online people, if you have any questions, then we can do.
Fascinating. And because we can't see the chat box, so probably we open the floor for questions. We start with the online audience, and if you have any question, just unmute yourself or raise your hand, and then you may have any question from online first. Yeah, so we see a hands up. Is that way? Yeah, so go ahead, please. I can't see.
Hello, everyone. Can you hear me?
Yes.
Thank you. I'm Xinjie Wei from China Animal Health and Epidemiology Center. Thank you very much for your great presentation. I've learned a lot, and I have one question for the part of validation of statistics Indonesia population data using herd dynamic model. I have read your paper, so I have such a question for you. My question is that if the statistic data is underestimate, I mean that the data doesn't reflect the real world. Maybe it's underestimate about the number of animals, the production industry. So will the parameters come out from the model, the diamond diamond herd model, will it be overestimate, such as the morbidity, mortality rates? Will that be overestimate, and how to deal with such problems? Thank you.
Great. Thank you so much for the question. And I think for sure it's relevant for China as well. I know the Chinese livestock statistics quite well. The answer is, as I mentioned, that using the herd dynamic model can show whether the statistics are internally consistent. So whether the balance between reported offtake and production and the population level and even the population structure, whether that's internally consistent, and then whether the growth reported across the years is consistent with the parameters. But what it can't tell you is like whether that population, the initial population estimate, is too high or too low. It will just tell you, okay, this is internally consistent. I think that was the first part of your question. The second part is whether the mortality and morbidity parameters will be valid. They will be valid for the reported link between production and offtake. So, and that's somehow like that link is independent of the absolute value of the population. So in my opinion, it would still be valid to use those morbidity and mortality parameters, even though we might not know the absolute value of the population with accuracy.
Thank you.
Thank you, Dom. Any more questions from online? Okay, probably we open the floor to our colleagues here. Any questions? Yeah. Yeah.
What is how are the cattle fed? Are they in large numbers, such as you find in Australia, or is it small? Do they forage, or are they lot fed, and so on? And does this make, how much difference does this make in terms of the weight that you're looking at and the possibility of disease?
Yeah, okay. So it's a multi-part question, but a very, very good and valid question. And the answer is, it depends what part of Indonesia you are in as to the production system. But so you have two main types of production system. So there's the backyard production and then lot feeding. So a lot of Australian cattle come to Indonesia and are fed in large feedlots in Lampung or even in West Java. So that's one production system, but that's very similar, I guess, to an Australian feedlot. So large concentrations, fed concentrate feed and forage and other like maize and soybean meal. And then the backyard production systems are cut and carry systems mostly. So the cattle are like tethered either in like small sheds, and then the grass is cut and brought to them. Maybe Dai, I can see Dai is online. Dai might have more information than me on whether there's any more extensive cattle grazing systems in Indonesia.
In Sumba, so in
okay.
Nusa Tenggara Timur, it's quite poor country, I guess, very challenging, and they have more extensive systems there. But where most of the livestock are, it would be more intensive, 1 or 2 cows in the backyard or even the back room of the house.
Great, super. Thanks so much, Dai. We've seen pictures of the cattle sheds and in a particular village, and especially in the densely populated areas. Like each household will have like a shed, and then there'll be another shed right next to it, another shed, another shed, another shed, with 2 or 3 cattle, and then the grass is cut and brought there. So you can imagine for disease. So for example, for a highly transmissible disease like foot and mouth disease, if one gets it, then all of them in that intensive. Even though it's backyard, it's somehow like very much on top of each other system.
Scott Walter,
Oh yeah, I know Scott very well.
told me about a project that he was working on, and this was 20-some years ago.
Maybe Jing knows about it.
They would give, they'd take a small calf to a family, and the family would feed it and so on. Like they would, in a sense, very much like the way they would raise pigs.
Yeah.
Just raise a couple of them, and that way it would increase the beef available in China and also give people some income.
Yeah, absolutely. So there's a number of different production systems and models that have been tried in different projects. Jing also works with Scott. So did you work on any project in Indonesia? Okay. Yeah. And then you were asking about if that made a difference in terms of the weight. When we had that little the grid of cattle, so the different ages and the different breeds, that took into account like that some breeds are kept in different production systems, so like that was taken into account by, I guess, the different weight at different ages. So that's partly dependent on the breed, but then also partly dependent on the production system that they're in. Yeah.
Fascinating project. Thank you very much for the presentation. I have something that wasn't entirely clear to me. I thought it was really interesting when you were showing the value and how you have the use value and the non-use value.
Yep.
It wasn't really clear to me whether you take the non-use value into your calculations or if you just looking at the use value. Because I read actually a paper that you wrote on ASF and in the Philippines.
Yes.
And how there's such an emotional attachment to pigs, for example. So even when farmers get financially compensated, they would sometimes consider the pigs as their sons.
Yeah.
How do you put it value in that?
Yeah, that's one of the big challenges that we have. So you have a multi-part question, so I'll answer the first part. In this study here is absolutely, we only consider the use value. We recognize that the non-use value and the sociocultural value are very important. Sometimes it's really extremely difficult to put a dollar value on those sociocultural uses. And you can see, like, we try to express it in the titles of the papers. So we have one called Beyond Numbers and another one, Counting the Cost, so trying to express those values. For the cultural value, we did a study in Timor and looking at the potential impact of ASF in Timor. And we used to estimate the cultural value, we used how much people would have to pay for a pig that met the requirements of a ceremony if they didn't have one themselves. So we use that as a proxy, but it doesn't come close to estimating the real value. Myself, even though I'm an economist, and economists tend to like to put dollar values on every single thing, myself, I think there are some things that you just can't value. I mean, if you were attempting to do it, you could probably try to value the mental health impact and say, okay, this many days of work were lost because the person was traumatized by their pig being shot in front of them. But normally we try not to do that. Yeah, we try to encompass for the beyond farm gate and beyond direct use value. We try to do as much as we can to explore the socio-cultural value, and then as much as we can to look at the value along the value chain as well. And that's what we're doing in Nusa Tenggara Timor at the moment, and East Java next month. And I just heard also in West Java the month after, so we'll be busy. Yeah.
Just follow-up question. So, this research hopefully goes into policy making.
Yeah.
Does the non-use value come into policy making, and are there other researchers or kind of supplementary kind of research going on that can also fit into policy because it's purely rational economic decision making, which is kind of the world we live in. But
Yeah.
you know, are there processes around that in terms of decision that can account for more than what is in one model?
Oh, it's a good question. And again, like the answer should be qualified as far as I know, and in different places. I can say in Indonesia that people are aware, and policymakers are aware, but I think that it's not taken into account as much as it should be, probably at a national level. Whereas at a provincial level or a local level, they're much more aware of this non-monetary value. And I mean, part of our work and part of the reason that we're in this project to start with is to bring that angle. We started off essentially just looking at policy and social impact, and then our remit sort of extended to economic impact as well. Mm. Mm. Yeah. Yeah, we have with Tarni, who's unfortunately, as I said, is not online today because he's not well. But Tarni and I started work in 2019 on developing a socioeconomic and livelihood impact assessment tool. So we have a whole, and especially like applied to animal disease. So that really looks at, starting from a sustainable livelihoods approach, so looking at different capitals and then looking at the impact of disease potentially on those capitals. So the paper that you were referring to in the Philippines sort of follows that, looking at not just financial capital, but also social capital, et cetera, et cetera. So this work is grounded in that methodology, but also we have another methodology that we use for the value chain analysis, which is making value chains work better for the poor. So that's we started off doing the poor, but now it encompasses JEDC as well. So yeah, that social aspect, I think as they become older, it's like becoming more and more and more important in my work, rather than just saying how many dollars is that worth? What's the net present value of this? Exactly. And we try to develop a dashboard also to look at, for example, the impact of animal disease on sustainable goal, like the achievement of SDGs. And part of that was like in terms of the indicators that we can put numbers on, but then another part is like really looking at the social part, the social aspect, the non-quantifiable aspect. Yeah.
So I can see that it's, in the value of the livestock, there is two models I can see here, like where high density, high value, high volume, the cattle and the livestock, but also that in the poorer area there is lower density, but the value in it for per capita per person per household is still very high.
Yep, exactly.
So we can see that there is intensive level farming, and there is like backyard, level of farming, and both of them are very important. Yeah. Similarly, in Vietnam, we also see like the government in Vietnam and trying to moving the industry toward the more intensive high value industry, but you can see it's still. There is still 50% of the production is still from the backyard and small farm. And from the development point of view, we still see that the value of the small farm and backyard farm is still very important for the poor and for the rural area, for the remote area. So your kind of data is not only significant in terms of knowing the value, but it's the distribution and the different model, and if we only see how to improve the value, that is maybe like or different budgets. The poorer and the one who their livelihood is depend on the small farm or the career that they have. Similarly, in Vietnam, when we consider the health security measure, biosecurity, and other requirements for the farmer. We also having a consideration that if we
put in too much strict biosecurity measure for farm. That may disadvantage the small farm, because the larger farm you can apply very strict separation and biosecurity issue measure. But when small farm, they live very close with human, and we in Vietnam also have the problem of captive wildlife farm. And wildlife, livestock, pet, and human all together in the small farm. That is where a lot of biosecurity is happening. But we still have to be consider the livelihood. We do not want to get involved. This one.
Yeah.
Recommend.
Yeah, no, it's a very interesting comment. And it shows the complexity of, like, if I was a policymaker there are so many competing things, you know. I think Jing and I also discussed this morning about like the policymakers want to achieve this goal, but then if you achieve that, then maybe you have a very different outcome than expected. I just came back from Laos, and they have the most beautiful biosecurity system. It's like gold standard for export of cattle to China. And part of my work there was to see what the possibilities for Lao farmers to join that system. And right now the possibility is zero. They just don't have the right type of cattle or the right biosecurity or the right breeds or anything to join this gold standard system. So on one side, they have a very good policy and very good system, but the result is not as intended. So it's some things like these complexities in Vietnam, Laos, Indonesia, even we presented to our colleagues in Ethiopia. They said same. It's the same challenges.
One more last
Yep.
question for David.
In Chinese society, meat would be preferred if it has been raised naturally on vegetable scraps and things like that, as opposed to feedlot. You get the same sort of differentiating value. So you pay more for cattle or for beef or for chicken or anything else that's been raised, in a sense, individually in a farmhouse rather than something from a feedlot. Does that come into it in Indonesia at all?
I think, well, I mean, I'm not Indonesian, so I can't speak from an Indonesian perspective, but from what I see, a lot of the beef in Indonesia is processed. So it's processed into bakso balls that are eaten with noodles, for example. So for that, you don't need like backyard or like it's so much processed. But the other thing that I see in Indonesia and in Vietnam and maybe like in China is the same. Since COVID, people are much more used to having chilled product or even frozen product because during COVID, that's what they had. And so that demand for it's got to be fresh from the wet market, killed that night, and I go there that morning and get it. That's like dropping very rapidly. So then you see these longer supply chains with different types of production. So commercial and backyard production coming in. It's quite a rapid transformation, I think, for supply chains in Southeast Asia. It's formalization of trade barriers, length of supply chain, and then there's more acceptance of frozen and chilled product. I don't think there are any other things up there.
Thank you, Dom. Such a fascinating talk. Thank you for the audience and from online and here for such a lovely discussion.
Yeah.
Thank you all.
Great. Thank you.